we'll see how far we get here. So chapter 2 has to do with parallel lines. The 4, do you remember, corresponding alternate interior, alternate exterior, and CIAs, right? If one of these is true, then lines are parallel, and it goes the other way. If lines are parallel, then you're guaranteed all 4 of these are going to be true. Okay, but remember, it's only these 3 where you have congruency, and the CIAs are supplementary, right? 180. So just remember that. We also have polygons in here and various items. Where should I start? I'm just going to go, let's maybe do this one here. So always remember, if you see a triangle, you should be able to use that in your favor. Okay. So please, when you do these ones, tell me where you start. If you've already done this, you can either go ahead and keep working on what you were doing, or just follow along as you can. Okay, let's see here. I look at the number, there's only one number here, and these lines are parallel. Okay, so and this is the transversal I'm going to travel on, and these are called alternate interior. So I can say that A is going to be 41, and my justification is going to be alternate interior angles are congruent. B is this one, and here you have to just remember that you have, what kind of triangle do you have here? You have an isosceles triangle. So if this angle, right, if these two sides are the same, then so are the angles across them. So B is also 41. B is 41, and you would just say isosceles triangle. That's the only reasoning. So you can maybe make an arrow. Hey, if that side is the same and this side is the same, so are the angles across those equal sides. Angle C, how could you do that? I know that this line is parallel to that line. I'm going to travel along that transversal. Travel along that until you get to here. Right? Emphasis on the parallel line. So B and C are called, anybody remember? One is inside. So if this is your sandwich, right? One is inside, one is outside. So they're corresponding actually. If C had been here, these would have been CIAs. Right? But one is inside, one is outside. So C is corresponding. So it's going to be the same as B. So it's 41 degrees. But the reasoning is corresponding angles are congruent. And if you want, I have no problems with you writing in the angles, right? You write down that's 41, this is 41. Because sometimes you can tell that it's true, or sometimes you can also tell it's like, wait a minute, that's not true, right? Based on the angles. D, this one, I'm going to use the sum of triangle because this one and this one, these lines are not parallel, so you can't use any of the 4. You cannot use that, so I'm going to use sum of triangle. So we're going to go 180 minus 2 times 41 essentially. That's 82, so that would be 98. So 98 degrees, and I'll just say sum of triangle is equal to 180. That's my justification. And for E, you should recognize A and E as they're vertically opposite. So E happens to be 41 as well. And you would just say vertically opposite angles are always congruent, no matter what. This is a backwards question. Do you need me to review that? Anna says no. Okay. I have done that on the test, and I've also done that on the review. So I'm going to leave those. Let's keep going here. I'm going to go to 9. Question 9. This is on page 8. You can bet on this one pretty much on inscribed polygons. Okay, so the first thing you must do is focus on the polygon that you see when you zoom out, right? So I'm gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. This is the one we don't have a name for. Okay. So 11 sides. Where should I start? I would say the interior angle is probably your best start, right? This is the interior angle of the big polygon. So I'm going to actually start with A. And I will just say angle A is 11 minus 2 times 180 divided by 11. Okay, so that gives us 9 times 180 divided by 11, 147.27. Please round to 2 decimals if you do get a decimal. That's enough for justification. I understand you've done significant amount of calculating there to warrant a mark. So that's done. A is done. I will now focus on this diagonal creating an isosceles triangle. Okay, so B can be found by just going 180 minus the 147.27. Right, I'll subtract the one angle I know and dividing it by 2. That's 1637. So B is done as well. And actually now doesn't really matter which way you go. Once you have your interior angle, you can tackle any of these shapes that are created by the diagonals. But I'm going to go with C here. This is a trapezoid. And this is a 1, 2, 3, 4, 5. This is a pentagon. And this is a triangle. Isosceles. They're all isosceles, by the way. But a trapezoid, we know that the sum is, it's a 4-sided shape. 360, right? A pentagon, I forgot. Remember the sum is 5 minus 3, right? N minus 2 times 180 gives you the sum of any. So that's 540. I know that a triangle is 180, so I'm not going to bother with that one. But there we go. So let's do the trapezoid here. To figure out the trapezoid, maybe I will do this on our this interior angle that I calculated happens to also be, right, these two here. So they're part of the big polygon, but right now specifically inside of that trapezoid. So I'm going to go 360 minus 2 of those interior angles. And that answer I'm going to divide by 2. $360 minus 2 times 147.27. It equals, and then divided by 2. 3273. All right, we got that done. C is done. Now I'm going to move into, let's say, this pentagon here. So I always focus on, I want to use the polygon, the original, as the exterior here, and then just that diagonal that creates that one. So a pentagon, to find this angle D here, I'm going to go 540 minus, how many interior angles does this one have? Just count here, 1, 2, 3. I'm going to highlight this here. I'm going to highlight that there because everything hinges on the pink one. So there are 3 interior angles there. So minus 3 times 147, 27. All of that divided by 2. $98.19, and don't forget to divide by 2, so that's $49.10. That rounds to 10, like that. And then E. How do you find E? E is different. Remember, there's 2 diagonals here. So you can't use what you've been doing so far. What I will do is, to find angle E, I'm going to first show you what I do. I will take the interior angle, 147, 27, and I will subtract. If you notice that if this is C, so is that one. I'm going to use a different color. C is also here. And if this is D, so is this angle right there. That is also D. So in order to find angle E, I take that whole interior angle that's found at this corner. You're with me, right? Am I going a little too fast? If you did this, then you're just following, right? So 147.27 minus C minus D. I will show my audience, like, what is it that I'm doing here? And now I'm going to go and grab C. And on the exam, I would honor this. Like, if you made a mistake upstream, I would still give you the mark for this work here if you do this correctly. Okay. And that's 65.44. F over here is simply the interior angle minus C. Right? It's just 147.27 minus angle C. And C is 3273. I probably won't be asking this many angles, but I could ask any of these angles. So it's 114.54. And G, here it is. G is over here. I'm just going to do the same thing, 147.27 minus angle D. And D is 49.10. That's 98.17. That's it for this chapter that I'm going to cover. Let's move on to trigonometry. That would be on page, with me. Let's go to page 10. Question, let's do question 3. Before I start, I would like you to sketch this one. Sketch the scenario to the best of your ability. And I want to see how you did. Rescue helicopter receives a distress signal from 2 different groups that are trapped by wildfires. The helicopter leaves the helipad and heads at a distance of this in this direction. So you're going southeast. So if you're going southeast, this is south and this is east, right? So maybe start over here. So make one of these and do a compass rose. So when it says south, that's where you start measuring from. Okay, so south, and 67 is right about there. Where's my ruler? Oh, it's hiding here. This way. And this, so this is 67 here. It's very important to put that in the right place. It doesn't go there, it goes in here. And we go 108.5 kilometers in that. So the first group here picked up. Then we're going south 38 west. So from here, I'm going to make another compass rose. Okay. You're going south, so you start measuring from the south line 38 west this way. We're going this way. And the 38 goes in there. Okay. And we're going, they don't tell us how far we're going here, but we're flying back 127.8 to the starting point. So this is where it's very important not to get this one wrong. Do not assume that you're perfectly lining up here and then flying back. I would actually say it's better to go here, like a little bit of an incline here, or if you want to shoot past, that's fine. But how about this? I'm going to extend, because the south line goes on indefinitely, right? But here we have, so what I will do is make my red line, this is flying back. And we know that that's 127.8 kilometers. And you should notice that the 67 is not inside the triangle. It is with respect to the south line here. But it's going to help us. It's going to help us because this line is parallel to this line. Okay. So we can bring this over to there, 67 right there. So that would be step number 1. Sorry, actually, this line is parallel. This is also true, guys. But it's these 2 parallel lines that we're using here. Okay, to bring this over. And now we can make a, I'm going to make a copy of it. And a clean version. So this is the helipad, first group, second group. We know that this is 108.5. We know that this is 127.8 kilometers. And we are able to find this angle here. This we're able to find because we know that there's a 180 here along this north-south line, and we have either one of these angles given here, so we can easily find that one. So we're going to go 180 minus 67 minus 38. And what do we get there? 75? 75 degrees. Okay, that's this angle right there. So I'm going to plug that in like that. So you like it's too good to be true to have a 67 and then another angle. I know there's creative ways students come up with numbers there, but don't make that assumption that the 67 is part of our triangle. So we sketched and labeled. We put some letters to it. B. Now we're going to start to solve. Calculate the distance between the first and the second group. And I tell you that this is a multi-step question. So we're going to figure this one out here. Let's call this X. Okay, so what can we do here? What law are we going to use to start us off here? Do you have a pair? Yes, I do. Okay, if it's SAS, then it'll be cosine law or side, side, side. But in this case, we have a pair. So I will maybe just say there's a pair. We use sine law. So sine of 75 degrees over 127.8 is equal to, what is it that I can find at this point? To find the side I require, I need this angle, which I do not have. But I do have this side, which allows me to solve for that angle. So let's just go for it and do that for now. So sine of S over 108.5. Sine of S, you just have to cross multiply and divide, right? 108.5 times sine of 75 divided by 127.8. Angle S will be found by going sine inverse of whatever I get here, which is going to start with a 0. It's going to be 0 point something. 108 point, oops, times sine of 75, oops, divided by 127.8. That's 0.82 and something. Angle S is second trace, no, sorry, I'm in a different world. It's not second trace, is second sine, right, inverse sine of that. So that's 55.09 degrees. Important, because that's going to allow me to figure out angle H. I know my key is probably a different letter that I've used. The way I know myself, I always deviate from the script. So 180 minus the 75 that I found minus the 55.09. So let the marks tell you how much work will be required. That's 49.91. Also important. I'm going to break this here. Now I have that angle, right? This angle, which will allow me to solve for that side. I will start with the same pair again. There's nothing wrong with using that. It's probably the safest because that's the original, right? And now we're going to use sine of 49.91 over x. And then you cross multiply, right? 127.8 times sine of 49.91 divided by 127.8. There's no inverse necessary because we're not finding an angle. And that is 101.22 kilometers. Which is the shortest side, and it's across the smallest angle. So we are good. We're in business, right? question? Jessica? Bring it, bring it. Is there a mistake? Yes, thank you. Everybody's scratching their heads, right? Thank you. Appreciate that. It's still the same answer though, because I copied it off my notes right here. Thank you. That's a good one. It's mistakes like these you will find on my key, perhaps. So if you come and talk to me, you'll look good, and you'll look good because you are reviewing. Okay, that's it for. It's not the only scenario. I think the next one is cosine law. If you try 4 on your own. Let me go through one more. Like, remember the ambiguous case, figuring out how many triangles are possible, how many solutions? We'll do that. Because they're actually easy marks if you know what you're doing. And it shouldn't take you a whole lot of time, right? So we'll do that. Okay. You know what my next strategy is going to be? I'm going to make shorts of all of my lessons. And then you're just going to scroll. So, ambiguous case. Oh, there you go. Oh, got it. I have to join the trend. Okay, keep going. Ambiguous case. I added that towards the back, page 21. I kind of just had a separate section for it. 21. Let me see if I can summarize this on here, on this piece of paper. Okay. So the first, maybe let me write it down first and then copy it. Hold this, like I'm just making this up as I go. The first branch is whether this is an acute or obtuse triangle. Okay, that's going to be your first question. Like, what kind of angle am I given? Well, actually, everything starts with, is this an SSA? If it's an SSA, well, now we need to determine, like, hey, is there even a triangle possible? You need to first see, well, is that angle acute or obtuse? Let's do the obtuse first because that's the easiest one of them all. It will look like this. Do you remember the wording I used for this one? It had to do with fishing. Rod and string. You remember that? So this is your rod and this is your string. Let me see if I get this right. String is always your main character, okay? If the string is greater than the rod, you have one triangle. If the string is less than or equal to, like if it's exactly the same, you still don't have a triangle. Okay, so there's 0 triangles, no solution. When it comes to acute, there's a bit more that goes with it. Maybe for the acute, wait till I'm done. Okay. If the string, oh, maybe I should do the diagram first. That's why I told you wait. It will look like this. This is your rod, this is your string. So if you look, right? And the string is greater than or equal to the rod, then you have one triangle. You look at the numbers. You're like, let's see here, right? String, if that is a 10 and this is an 8, you have one triangle. If this is a 10 and this is a 10, one triangle. If it's the same, you're still in business. But if string is less than the rod, then what do you have to do next? You have to find something. You have to find the height. Find h, which is rod times sine. I'm just going to introduce a here. I'm just going to call that angle A. So that's how you find it. Find the height. And then you have three options. String, string, string. Okay, so if the string is less than the height, 0 triangles. If the string is greater than the height, you have 2 triangles. If the string is equal to the height, you have one right triangle in particular. This has a much more in-depth and detailed explanation if you go to your booklet. But I tried my best to summarize. This would be like a short. So here we go. That's what you have to do. So is it SSA? If it's not SSA, this whole thing, you just like forget about it. Like it's one triangle, that's it. But if it's SSA, you need to first branch off. Is it this or this? If it's acute, check rod versus string. If it's greater than or equal to rod, then you have one triangle. If it's less than, you need to find the height, and then there's either 0, 2, or 1 triangles. So here we go. Let's try this. Triangle ABC, angle B is 34, and then you have 2 sides, and this, the fact that side B and angle B is there, that gives us SSA. It tells us immediately this is SSA. You have a pair. You have a pair and one more side, SSA, sine law. And this is acute because it's less than 90. So we do one of these. 34 goes there. The side across from it goes here. And the other side that's given, you force it to be over there. This is my rod, and this is this string. So we immediately, by looking at this, we go, hey, string is less than rod. We need to find the height. That's 4 times sine of 34. That's 2.24. We don't have units, so we'll just leave it. So that's 2.24, like the height. So we now recognize that the string is greater than the height. So if you look at my flow chart, if the string is greater than height, right, you say there's 2 solutions. Try a few on your own, see what you get. I just warmed your engines up a little bit, so try that. maybe I'll just go over it quickly before we go. I'm going to go quicker than what you'd like me to go. Okay, you can slow it down later if you want. SSA, right? Because you have two sides, one angle, and these are across each other. Because it could be SAS. Could be. But it's not. We know that it's a pair. So SSA, and the angle is less than 90, so it's acute. So we have something like this going on. 13 degrees. X, which is across the angle, is 12. Y is 15. So we would say that if this is the rod and this is the string, we'd say string is less than rod. Find the height. We're going to go 15 times sine of 13. It's 3.37. And so string is greater than the height, therefore also two solutions. Okay? One more? Or what's this going to be? I see a pair. String is greater than the rod here. You notice that? So because of this, it's SSA. It's still acute. So if you did your diagram, B is across the angle you're given. So it's 5 and 4. This is the rod. This is the string. String is greater than rod, therefore one solution. That's it. Don't bother finding the height. Okay? Don't bother finding the height there. RST, we've got a pair and another side. SSA, obtuse, easier actually this one. You'll never have to find the height for obtuse cases. Just make sure your diagram looks like this. This is 130 and 20 goes here, 16 goes there. This is rod, this is string. String is greater than the rod, therefore one solution. Okay. Another one, you've got a pair and another side, so this is SSA, obtuse. Oh, we don't close it because we don't know it yet. 170. M, so this would be 19. This is 11. Make sure you tell me this is rod, that's string. So S is greater than 19. Sorry, than rod. What am I doing? Then rod, therefore one solution. There are more on the next page. Don't worry about solving a triangle with ambiguous, like with more than one answer. You just have to be able to identify how many solutions there are. Okay, so page 22 has more. And the key, obviously, solve the whole thing. You just have to focus on how many solutions there are. That's it.